Hello everyone. In this video, I'll show you how to make an object move as if it's attached by an elastic rope. This effect isn't exactly accurate to real life, but I like the effect that it creates, and it's a little bit more forgiving for gameplay. This effect could be used for whatever you want in your game, from a stretchy noodle that the player grabs onto and swings on, to an extra scary leash for a monster in a horror game. In my game, I'm using it so that my spider character that climbs around will have a more natural feeling when it's reaching out to its limits, so that instead of just stopping short, it'll kind of stretch and reach out. Here's the general logic behind how everything works. There are two relevant objects, the attachment point and the attached object. First, we're going to define a distance where the elastic will start pulling on the object. When the object exceeds that distance, we'll scale up a force that rebounds the object back. But if we just apply the force, no matter how we adjust things, one of two problems are going to happen. Either the force is too weak, and so the object will just continually keep going and not rebound fast enough, or the force is too strong, and so then the object will be pushed all the way to the other side of the boundary, way faster than it hit the boundary in the first place. But what saves the day is a property of rigid body nodes in Godot called the damp value. What this property does is it slows the velocity. It makes it feel like the object is moving through a thick mud, hence the name damp. So what we're going to do is when the object is outside of its boundary, moving away from the attachment point, we'll make the object very damp so that it will slow down at the appropriate time. Then, as soon as the object hits that point where it stops moving, and now it's moving back towards the attachment point, we'll remove that dampening so that it still shoots back, but at a force that we can control. Okay, let's jump into Godot and then take this step by step. Okay, so we're in Godot. First things first, for everything in this tutorial, you could do it in 3D, except for the way that I test the object. So you'd have to figure out a different way of moving the object around, but aside from that, everything else should work. In this tutorial, though, I'm going to do it in 2D. First, I'm going to define the attachment point. So I'm just going to add a sprite, just so that you can visually see where the attachment point is. And I made a PNG already. I can just drop this in, move this over, and I'll scale it down. Then we'll define the attached object. Now the attached object is going to be a rigid body 2D. That way we can access those properties, the damp property, the linear velocity, all that good stuff. So let's put a rigid body 2D. Rigid body 2D requires a collision shape. So I'll put a collision shape 2D. And then I'll add a shape in the shape property. And I'll just make it a circle. Also, let's put a sprite as a child of the rigid body 2D so that we can visually see where the attached object is. And I'm going to scale that down as well, just the sprite. Now let's adjust the shape so that it's generally the same as the sprite. Okay, so now we have our attachment point and we have our attached object. Keep in mind, I'm transforming the rigid body 2D, not any of its children. So this is how I move the attached object. The attached object is the rigid body 2D. Okay, so now I have my two objects and I named them so that I don't get confused. Now, let's go to the attached object and add a script. And I'm going to define some things right away. Made some constants up here that we're going to use later. I made a constant for the shot power, so how fast will the object be shooting towards the mouse. I set that at 4. I made a constant for the force power, how strong is the force that rebounds the object. I set that at 300. And I set a constant for the damp power. How damp is the object going to become? And I set that at 0.16. Finally, I made a constant for the free moving distance. How big is our boundary? And I set that at 300. You can adjust these after you get everything working, but these are the numbers that worked in my other project, so I'm just going to use them in this one. So the first priority is being able to test. So the first thing that I'm going to do is write a function that will shoot the attached object to the mouse. I need the vector between the attached object and the mouse. That will give me what direction to send the attached object and how fast to send it. To get a vector, all I need is to subtract the mouse position from the attached object position. So I'm going to write a function called getShotVector. In this function, I'm going to write return. And what that's going to do is whenever I call this function, anywhere in the process, in any situation where I want to get the shot vector, whatever I type after return will replace the function. So it's like outputting a value. So return, what am I going to return is the vector between the mouse and the attached object. First, let's get the mouse position. So I'm going to type get viewport. That's the screen. And then dot get mouse position. Now I have the mouse position, and I'm going to subtract the global position. This global position is attached on the script. So this is relative to the script. Remember, the script that we made was on the attached object. So the global position is referring to the attached object. So I'm subtracting the mouse position minus position of the attached object. Now I need to tell Godot when to shoot the attached object to the mouse. So I want to do that whenever I click the left mouse button. I'm going to go into project settings. Input map is the second tab on the top. And then I'm going to type left click and add. Now Godot knows that there is an action called left click. If I press this plus, I can tell Godot what is the left click actually looking for. Then I go to mouse button, left mouse button. Now Godot knows that there's a left click action, and that left click action is defined by the left mouse button. To listen for the left mouse button, I use the process function, which is called every frame. So then I type if whenever input is action just pressed left click. So whenever the left click action that I defined in the project settings happens, then this condition is satisfied. Then I can press enter, and now anything I type here will happen when the left click is clicked. This is where we're going to set the linear velocity. Remember, this is attached to the script, so I'm setting the linear velocity of the attached object to get dot vector. Okay, so let's test. Press play up here, and then the attached object just falls. So I want to turn off gravity so that I can test properly. So I'm going to take gravity scale and set it to 0. Little side note, if clicking on this doesn't make everything appear, just click on something else and then click back, and then everything should appear. Sometimes it gets a little stuck. But yeah, let's set the gravity scale to 0, and now let's test again. And now, the attached object is now going towards the mouse. Now, there was that constant that I made here called shot power. So, in order to use that, I'm just going to type it, shot power, and I'm going to multiply by the get shot vector. And now if I play again, it just goes a little faster. I'm actually going to turn that a little bit down. So I'm going to turn that down to 2. There we go. And you'll notice that the further away my mouse is, the faster it goes, which is pretty good for testing. I have a little bit of control about moving it. Okay, so now we can kind of test the movement of the attached object. And you'll see that the object, if I click, is just going to keep going forever. So the next thing we're going to do is make the object rebound towards the attachment point. And when we wanted to move the object to the mouse, we got the vector between the mouse and the object. Now we want to move the object towards the attachment point. So we're going to get the vector between the object and the attachment point. So to get that vector, let's write a function called getPointVector. The vector between the object and the point. So to get that vector, we'll do a similar thing. We'll type return. So replace this function with, and then we need to get the attachment point position. So let's right-click the attachment point and click access as unique name so that we can easily reference the node. And then I'll drag it in. So let's return the attachment points, so dot global position. So the attachment point's global position, and now let's subtract the global position. Now we're taking the difference between the attachment point's global position, and again, this second global position is attached to the script, so this is the global position of the attached object. So we're getting the vector between the attachment point and the attached object. So now we have what direction and how far away the object is from the attachment point. Now we need to convert that into a force that we want to push on the attached object. Because remember, we have a boundary where we don't want any force at all to be applied. And then as it goes outside that boundary, then we want it to start getting stronger and stronger, the force. So we're going to need to write a separate function to put all of that together. And let's call that function getReboundForce. The first thing I want to tell this function is if the object is inside the boundary, don't apply any force. So I need to get the distance between the attachment point and the attached object. So I'm going to say if, and I'm going to get point vector. Remember, the point vector is the vector between the attached object and the attachment point. Then I'm going to do dot length. So I'm calling length. Length is an already created function that will apply to vectors. It's basically going to say how long is the vector. In other words, what's the distance between the two objects. So now I'm saying if the distance between the two objects is less than, remember we actually defined a constant, free moving distance. So if the distance between them is less than the free moving distance, then I'm going to say return 0. Replace this function with 0. So there's going to be no force. Okay, so I have the situation where the object is inside the boundary. And now if I type else, that's the opposite situation. So now we're talking about when the object is no longer inside the boundary. When the object is outside the boundary, I want the force to start at 0 right on the boundary and to get stronger and stronger as it pulls away from the boundary. So what we're going to do is create a variable that defines how strong is the force. Not direction or anything, just how strong is it. I'm going to call this force magnitude. And it's going to be a float variable, which is just a number. Defining the force magnitude will have two components. The first is how far outside of the boundary is the object. The farther it is, the stronger the force. The second component is going to be a constant that I made called force power. This is just going to be something that I multiply to make it stronger, faster, if I want to. First, let's get how far outside of the boundary is the object. So I'm going to get the distance between the two objects. That's what this is. And I'm going to set that force magnitude equals. So we have the distance between the two objects, and I'm going to subtract the free moving distance. Together, these two things represent how far outside the boundary is the object. Remember, this situation is the else, meaning we're outside of the boundary. The smallest this number is going to be is 300, because the distance between the two objects is 300 right at the edge of the boundary. As we go farther outside the boundary, this number is going to be bigger than 300. So by subtracting the free moving distance, we're subtracting the smallest possible value, and then getting what is left over. So that's how these two together become the extra distance outside the boundary. So far I have that the force magnitude is set to the extra distance that the object is outside of the boundary. I want a little bit more control over that, so I'm going to put parentheses around these, and I'm going to multiply by the force power. Now, the force magnitude scales with how far out it is, but I can control it a little more by using the constant that I defined up here. So I can make it scale faster or slower, however I want. I found 300 to be a pretty good number. So we have how strong is the force magnitude, and now we need what direction is the force going in. So let's make a new variable called force direction. This is going to be a vector too, because directions point on x and y. They point somewhere. So that's how we're going to make the force direction. So let's set it equal to the get point vector is how we're going to get the direction. Remember, this get point vector gives us the vector between the two objects. So it is pointing in a direction. However, the get point vector also has like a length to it, so we want to get rid of that, so it's just a direction. And we have a function that does that for us. It's called normalized. So now we got the force direction by getting the vector between the two objects and normalizing it. Now we have everything that we need to build the actual force and get the rebound force when it's outside the boundary. So we're going to return now. Now we're saying calculate these things, and now replace the function with the rebound force. The rebound force is going to be the force magnitude multiplied by the force direction. These two things are what you need to make a vector. How strong is it? What direction is it going in? The next question after we finally define a function that we want to run is when are we going to run the function? In this case, we're going to run this function every single frame because it's always got to calculate what is the force and apply the force. So in the process function, with no if condition, just always going to apply it, we're going to set the constant force. If you go into linear constant forces, you've got a constant force property. So we're going to set that equal to get rebound force. Okay, let's test it and see how it works. Oh, it looks like we've got an error. It says error setting property constant force with value of type float. Where's the float? Well, the error is when we tried to call this function get rebound force, and I see that we're returning a float right here. So that's the problem. We are setting constant force. If we look in the inspector, constant force has an x and a y, so we can't set it to a float. So instead of putting 0 there, we're going to do vector 2, and we're going to do dot 0. So this is a vector 2 with 0, 0. Now it should work, and let's test it. Okay, so now, if I shoot the object away from the attachment point, you can see that it is rebounding towards the attachment point. It's looking a little bit messy here, though. It looks like the force is a little bit too strong. So, let's turn it down. Let's see what 100 looks like. That kind of works, but as you can see, it's still got that problem. This is kind of what I was talking about in the original breakdown of the logic. I can make this weaker and weaker, but if I make it too weak, it's going way outside the boundary. And if I make it too strong, it's just going to weirdly bounce back and forth faster and faster. What if I make this 10? It's going way too far now. So this is our problem that we run into and why we have to use the damp property. Real quick, before we start doing the damp, I want to see what this system looks like with the gravity back on. I'm going to turn the gravity back on and let's test it again, and maybe that'll help us adjust some numbers. So yeah, the force seems to be a little too weak, so I am going to turn it up. I'd like the force to be kind of comparable to the gravity. So let's put it up to 40. And I'm not going to adjust it too much, just a little bit, just so that I have a general idea. Okay, that looks a little bit better. So I want the damp to work pretty similar to how the force works. The way that the force works is the farther away outside the boundary the object is, the more force is applied. I want the same thing to happen with the damp. The more the object is outside the boundary, I want the object to become damper and damper, so it slows down more and more. If we look at the damp over here in the inspector, we can see there's a slider. So damp is actually a floating point value. So it's just a number. So what I'm going to do is I'm going to copy this entire function, and I'm just going to change it so that instead of returning or replacing itself with a vector, I'm going to return a number. So let me copy this function, and I'll rename it getDampValue. Let's go step by step and see what things we have to change. So first of all, the condition is the same. If the object is inside the boundary, we want to return 0 damp. There's no damp. So I'm going to just change vector to 0 to 0.0 because now we're outputting a floating point. Otherwise, aka the object is outside the boundary, then we have a little bit of difference here. So we do not need a direction. I'm going to completely delete that. And I'm going to rename the force magnitude to damp value. And then instead of force power, I'm going to multiply by the damp power. Then we can return the damp value. So I took out the direction and made it just calculate the damp amount based on, again, how far away outside the boundary is the object. Multiply that a number that I can control, and then output that. Now, let me actually set the damp value to the value that I just created a function to calculate. So we're going to say linear damp equals get damp value. And let's test that and then see how that goes. Okay, so we've got this situation now where the object is acting more like there's a elastic relationship between it and the object. I'm finding it a little bit difficult to move the object. It looks like because I added the gravity, the shot power needs to be increased. So I'm going to make this 5. And as you can see, the object stops when the elastic goes too far. And it doesn't stop short, it stops and stretches a little bit. So it gives us this elastic kind of feel. And you can adjust these values if you want. I'll take the power down a little bit on the force. And then that will change how the object rebounds. You'll notice, ever since I reduced the power on the force, the rebounding force, the object kind of floats in space in a straight line in this really weird and unnatural way. That's because the damp value is still active even when the object is moving towards the attachment point. So that's the next thing I'm going to do. And the final thing to make this effect is I'm going to make it so that the damp value only applies when the object is moving away from the attachment point. That way, when it rebounds, it'll rebound in a more natural way. So how are we going to know when the object is moving towards or away from the attachment point? I'm going to write a function and I'm going to use the dot product in the function. You don't really need to know exactly what the dot product does. Just know it'll help us figure out which direction the object is moving. Is it moving towards or away from the attachment point? So I'm going to write a function called get velocity relative to point. All I'm going to write in this function is replace yourself with, or return. This function is going to replace itself with the output of a dot product. So I'm going to dot product to the two vectors, the vector between the two objects, and the vector of the velocity. So I'll do linear velocity dot dot get point vector. So it's a little weird how you do dot products in Godot. It's actually a dot function, and so that's going to be how you do it. So you put your first vector, then you call the dot product, and then you put the second vector. So that's how dot product works in Godot. So now we have the dot product. I'm going to then print the dot product in the process function so that we can see what kind of numbers come out. So let's print get velocity relative to point, and let's test it. Okay, so as you can see, it's kind of like a negative number and positive. And the number is always positive whenever the object is moving towards the attachment point, like right here. And it's negative when it's moving away from the attachment point. Okay, so let's get rid of this print, and then let's make it so that the damp value is 0 when the object is moving towards the attachment point, and then we calculate the damp value with our function when the object is moving away from the attachment point. So in the process function, I'll put if. Now I want to find, is it going towards or away from the attachment point? So I'm going to use get velocity relative to point. So if get velocity relative to point, now remember, when this number was printing a positive number, that's when it was moving towards the attachment point. So if I'm going to say if the velocity relative to the point is greater than 0, that's positive, then let's make the linear damp 0. Else, then we can make the linear damp equal to the get damp value. And let's get rid of this one where we were just setting it to the linear damp value all the time. So now the linear damp will be 0 when it's moving towards, and it'll calculate when it's moving away. Let's test it. And now we get a really nice, clean, elastic feeling. You can see it kind of rebounds, and it speeds up a little, kind of just like elastic would. Thanks for watching. I hope this tutorial helped you. Make sure you like and subscribe for more content, and have a good day.